Hello great nurses, welcome to the Nursing Career Pathway channel where we guide nurses on their pathway to success. In Module 1 of NUS 111 Applied Chemistry, we talked about the concepts and principles of chemistry and their application to nursing practice. Here in Module 2, we want to understand the nature of matter. As we all know, the circles to success are as follows. Must know for examination are marked with red circles. Orange circles indicate areas that are good for clinical, and green circles ask you to skim through this video at later times. Specific objectives for this module are as follows. Number 1, we will describe the physical and chemical properties of matter. Number 2, we will describe the physical and chemical changes that take place in our body. Number 3, we'll explain the chemical symbols of elements. Number 4, we'll describe the classification of elements, components, and their mixtures, right? Number 5, we'll discuss particulate nature of matter, which are atoms, molecules, and then ions. Number 6, we will then explain the structure and chemical combination of few elements. Let's begin with objective 1, to understand the nature of matter. What is matter? Matter is defined as anything that has mass and occupies space. What is mass? Mass itself is the quantity of matter that is contained in an object. All forms of matter are chemical substances. What are chemical substances? A chemical substance is any form of matter that is single in its composition. For instance, they cannot be separated into other kinds of matter by physical methods. These are chemical substances. It is a substance with specific, consistent ratio of elements or molecules that defines it. Example, water. Water is a chemical component that combines in the ratio of hydrogen to oxygen 1. 2 molecules of hydrogen, 1 molecule of oxygen. That is the chemical combination of water. So water is an example of a chemical substance because it has its own characteristics, its own qualities and behaviors called properties. Properties of matter could be physical or chemical. What is a physical property? Take note, this is a possible exam question. A physical property is a property or a behavior that is associated with physical changes. They can be determined at any time on the same substance, such as the state of the substance, the color of the substance, the odor of the substance, the taste of the substance, the density of the substance, the melting point of the substance, the boiling point of the substance, and of course the solubility of that substance. All these are physical properties of a substance. Based on physical properties, matter exists in 3 distinct states. So any matter can be solid, any matter can be liquid, and of course could be gas. So these are the states of matter. What about chemical properties? We've talked about physical properties, that they could be color, they could be odor, and so on and so forth. What about chemical properties? Chemical properties are behaviors during which a substance undergoes a permanent change. These are properties associated with chemical changes. Any change that is associated with chemical reaction is a chemical change. Usually, a substance that has a different physical property from the original substance is produced. So for a physical change, new substances are not produced. For a chemical change, new substances are formed. For example, the food we eat is made up of carbohydrates, fats, and protein, depending on what you eat though. If you eat any of those, they decompose into our body and into smaller substances, forming amino acids and glucose as the case may be. Based on chemical properties, the 3 classes of matter are elements, compounds, and mixtures. Objective number 2. We will describe the physical and chemical changes that take place in our body. Matter undergoes changes. These changes may be temporary, they could be reversible, they could be permanent, and of course irreversible, or very difficult to reverse. What is a physical change? A physical change is a change which is easily reversed and in which no new substances are formed. For example, Dissociation of common salt in water. The normal saline we usually use in the hospital is an example of the product of a physical change. How is it formed? Salt, which is a solute. A solute is a solid, right? Plus water, which is a universal solvent. When they mix, they lead to the formation of a salt solution. A solution can either be homogeneous or heterogeneous. A homogeneous solution is a clear fit solution. A heterogeneous solution is a non-clear solution. As we continue, the salt and water combination will give us a salt solution. We can get back our salt and water, showing you that this is a physical change. So no new substances are formed. Salt solution, if we want to get it back, we'll take it through a reverse backward reaction by evaporating the product of our forward reaction, which is the salt solution. We evaporate it at a specific temperature, and then we'll get back our salt solute and our water solvent. What is a chemical change? This is also a possible examination question. A chemical change is one which is not easily reversed and in which new substances are formed. Examples of chemical change in our body are as follows. 1. Digestion process in the body is a chemical change. For instance, you eat starch and then the product you get in your body is glucose. Another chemical change that takes place in our body is respiration. In respiration, the formula says that glucose will combine with oxygen, leading to the formation of carbohydrates, water, and of course energy. About 36 to 38 ATP of energy is formed in respiration. So we take in oxygen and we give out carbon dioxide. This is the complete formula of respiration. So whenever you cite respiration as an example of a chemical change that takes place in the body, ensure to cite the equation. The third change that takes place in our body is protein synthesis. Amino acids chemically combine to form protein in cells. Number 4, neutralization takes place in our stomach. That's also a chemical change. Excess hydrochloric acid may be neutralized by antacid or bicarbonate. For patients with ulcers, they usually take antacids. This is to shield or neutralize the acid chemical changes taking place in the stomach. Number 5, hemoglobin binding oxygen for respiration is an example of a chemical change. Objective number 3, we want to explain some chemical symbols of elements. It will interest you that we have over 108 elements according to the periodic table. However, for the nursing concerned field, we want to reduce it to very simple ones that we use on everyday basis. The first one is sodium. Sodium, the symbol is Na. The N is usually capitalized and the A is usually small. Please take note of chemical symbols. Just master them so that you know how to write a chemical reaction. Nursing relevance. Sodium is relevant to nursing in the sense that it is concerned with electrolyte balance and the function of our nerves. Clinical example. High potassium is hypernatremia. Low potassium is hyponatremia. So this is a clinical example. Hyponatremia is when sodium ion is less than 135 millimoles per liter. When the sodium electrolyte is less than 135 millimoles per liter, it will lead to confusion, it will lead to seizures. For us to correct it, we'll have to put up intravenous saline. That's our normal saline, which will help to correct this imbalance. The next one is potassium. Potassium, the symbol is K. It's relevant to nursing in that it is responsible with cardiac rhythm and muscle function. If it is high, it's hyperkalemia. If it is low, it's hypokalemia. For hyperkalemia, potassium ion electrolyte is higher than 5 millimoles per liter. How do we know? The ECG machine will read a peaked T wave. So the T wave in the electrocardiogram machine will be very high. Okay? So the medication involved is usually iazalate. So let's continue. Calcium, the symbol for calcium is C capitalized and A small letter. Nursing relevant. How is it relevant to nurses? It's relevant in blood clotting. It's relevant in bone health. Example. High calcium is hyperkalemia, low calcium is hypokalemia. Hypokalemia is reduced calcium in the body. How do we know? It is identified by the Schifozek sign, which is identified by facial twitching. Okay, normally, if cardiac arrest is involved, IV calcium gluconate is usually administered. Iron is given as capital letter F and small letter E written together. How is it relevant to nurses? It is concerned with oxygen transport in hemoglobin. Clinical example, anemia. Anemia, reduction of blood cells, right? If there are loss of blood cells, it will lead to fatigue. Normally, IV iron dextrine infusion is usually given, administered slowly to avoid hypotension, because when there is reduced blood in the body, it will lead to hypotension. Oxygen is given as O. Oxygen is relevant to nurses in that it is responsible for cellular respiration, cellular respiration of cells. Clinical example, hypoxia. Hypoxia, reduction of oxygen to organs will lead to cyanosis. Usually, oxygen is titrated through nasal cannula and is given or administered to such patients in order to increase their saturation level of oxygen. And at least it should be above 90. Should be above 90. The highest is 100, but anything above 90, 94 is okay. Should be above 94. Okay, we can see here SpO2 greater than 94 is fine. Objective number 4, classification of elements, compound, and mixture. In classifying elements, compound, and mixture, you have to understand that if you misclassify substance, you have to understand that any misclassification of substance will lead to medication error. So let's learn to categorize elements. We want to define elements and then their nursing application and then why it matters. The first element is zinc. But what is an element? An element is a pure substance. It's just one type of atom. Example, zinc used in wound dressing is an example of an element. Why it matters to nurses? Zinc oxide promotes healing. Elemental zinc is toxic if ingested. Normally, if you ingest zinc, is toxic, right? It's fatal, right? It's toxic. So basically, wound healing requires zinc oxide. Most wound dressing are accompanied with zinc oxide. What is a compound? A compound is when two or more elements chemically combine in a fixed ratio. Nursing application. Sodium chloride is an example of a compound in IV saline fluid. Why it matters? Our 0.9% normal saline is isotonic. If it is wrongly concentrated, it could lead to hemolysis if hypotonic, or it could lead to cell shrinkage. It could lead to cell shrinkage if hypertonic. So it has to be specific 0.9%. It is in line with the body cell. So it should not be greater than this or lower than 0.9. Mixtures. Mixtures are physical combined substance. Mixtures are physically combined substance. It could be homogeneous, it could be heterogeneous. Example is your dextrose saline. Your 5% D water in the hospital is a homogeneous substance. Heterogeneous substance, example is the blood. Your blood is made up of plasma and red blood cells. It's made up of plasma and red blood cells. It's a mixture. Okay, why does this matter to the nurse? For example, the dextrose, 5% dextrose in water is a uniform solution, right? It is safe for IV push. You can push it through the IV. It is safe. Okay, blood is a component in the hospital that is heterogeneous. Before transfusion, you don't just transfuse, you make sure that it is properly mixed, right? It's possible for you to avoid suspension before transfusion. We also understand a category of element, compound, and mixture, which is your colloid. Your colloid is a mixture of particles that don't settle. Okay, example in the hospital is your albumin IV solution. albumin intravenous solution. It helps to maintain oncotic pressure, usually in burns or sepsis. For patients with sepsis, that's infection, bacteria in the blood, right? Never filter clogged lines. Clogged lines are not filtered, they are just given because they are colloid and they are used to maintain burns and sepsis. Objective number 5. We want to discuss particulate nature of matter. Atom, molecules, and ion. These are the nature of matter. Let's discuss them. Particle definition, nursing application. Atom. Atom is the smallest unit of any element. Oxygen atom and ion atom are examples. For instance, in nursing practice, oxygen atom is being given as oxygen gas when they are combined. They help to enable patients to breathe well. In terms of administering oxygen gas, they will bind to the hemoglobin in the red blood cells. Molecule. 2 atoms or more than 2 atoms bond together to form a molecule. For instance, oxygen gas is made up of 2 atoms of oxygen combined to form oxygen gas. Water is also a molecule combined hydrogen into oxygen into 1. Glucose is also a molecule. C6H12O6, combination of 2 or more atoms forms a molecule. Nursing application. Glucose molecule is found in dextrose, 5% dextrose water. This will help to feed the cells. Ensure to monitor for blood glucose in order to avoid hyperglycemia. So you need to know this, that when a patient is diabetic, you also need to consider the kind of the water that is given to the patient. Another particulate nature we'll discuss is ion. Ions are charged particles. Examples: sodium ion, potassium ion, and calcium ion. How is it relevant to nursing? Potassium ion regulates heart rhythms. IV potassium must be diluted. Undiluted potassium ion stops the heart. Please take note, in the hospital, if you are not sure, ensure to ask questions. Potassium ion must be diluted before administration. Don't just give it IV push. Why are ions non-negotiable for nurses? Ions are non-negotiable for nurses because of the crucial role they play in the human body. Example is your sodium-potassium pumps, which ensure that your neurons of the brain are firing well. If they are disrupted, it will lead to the patients having seizures. You have to understand this. Example of when sodium-potassium pump is disrupted is when there is digitalis toxicity, right? Toxicity of digoxin. When the medication is given excess dose, it will lead to the stopping of sodium-potassium pump, and which will now lead to seizures, and if it's not properly managed, could be fatal. The second one is calcium ions. Calcium ions trigger muscle contraction. When calcium ions are low in the body, it could lead to tetany, which is spasm, muscle spasm. Okay, high calcium in the body will lead to kidney stones, so it has to be balanced. Okay, that's why we say hyperkalemia, hypokalemia. So it has to be balanced. Okay, the next one we'll talk about, ions are non-negotiable because of hydrogen ion, which helps us with acidity and alkalinity. So for acidity, the pH of a solution, when it is less than 7.35, high acid content in the body, it could cause altered mental status. So basically, in the psychiatric world, they usually take this very seriously. So ions are non-negotiable in nursing practice. Objective number 6, we want to explain the structure and chemical combination of elements. There are 2 main chemical combinations which we'll discuss. There are more, but for the nursing practice, we'll discuss just 2. So the first one is ionic or electrovalent bond, and the second one is covalent bond. Ionic bond or electrovalent bond is called electron transfer bonding. This is concerned with the transfer of electrons from a metallic atom to a non-metallic atom, during which a chemical reaction takes place. In this type, a metallic element or group loses from its outermost electron shell. So it is the metal that lost the electron. A number of electrons equal to its valency. The valency of an electron, or the valency of an atom, is the number of electrons present therein. These electrons pass over to the outer electron. So the electron of one element will move to that of another. Okay, so these electrons pass over to the other outer electron shell of the non-metallic atom. So the non-metallic atom is the one receiving, so it is negatively charged. Receivers are negatively charged, givers are positively charged. Non-metallic atom with which the metal is combining. By this means, an electron octet or stable state is left behind in the metal and created in the non-metal. So both of them becomes balanced state. Thus, they have at least 8 electrons in the outermost shell. Thus, the donor-acceptor principle is utilized. Which of these two utilizes the donor-acceptor principle? It is ionic or electrovalent bond. The metallic atom becomes positively charged, while the non-metal atom becomes negatively charged. They form an ion. Both ions now possess stable outer electron octet states, like a noble gas, and are held together by strong electrostatic force called electrovalent or ionic bond. Let's consider a neutral metallic atom like sodium and a non-metal like chlorine, respectively. So this is how they bond. Before the combination, sodium has 11 protons, and as we know, chlorine has 17 protons. This will not change. However, in that 11 proton, what makes the sodium 11? There are 3 electron shell. The first one has 2 electrons, 8 electrons, and lastly 1 electron. 2 plus 8 plus 1 will give us 11. For chlorine is number 17. The number of protons is called the atomic number, and this is the number that they possess in the periodic table. So chlorine is number 17. It has 3 electron shells. The first one takes 2, second one takes 8 electrons, and the last one takes 7 electrons. So this is not stable. However, we want to combine them so that both of them can get a stable octet state, which means that they will have both 8 as the outer electron shells. So this is how they combine. This valence electron 281 will pass to chlorine atom. So the external outermost electron shell 1 will now combine to this 7 on chlorine to complete 8. So after the combination, we remember that the proton numbers remain the same. What happens is that this 1 has left to chlorine, so it will remain only 2 and 8. Making it positively charged because it is a giver. Givers are always blessed. So this is positive, right? Just note that. Okay. So chlorine ion on the other side becomes negatively charged, and the number of electrons at the outermost shell is 8. So we have both of them having 8 at the outermost shells. So they are both at the octet state. They are both stable. Let's look at an equation. So sodium is the giver, becomes positive because it's giving out an electron. Chlorine accepts an electron and becomes negatively charged. Combining both equations, we have this, okay, forming sodium chloride, sodium positive and chlorine negative. Take a look at this diagram. This diagram illustrates the transfer of electrons, right? Sodium, which is 281, having 1 electron at the outermost shell, transfers this one to chlorine. Chlorine, having 7 at the outermost shell, receives this one and becomes 288, while sodium becomes 28. Both of them having 8 at the outer shell makes them stable. The next bonding we'll talk about is covalent bonding. In covalent bonding, electrons are not actually gained or lost by atoms concerned. They pass into a shared state. So electrons are shared and not transferred in covalent bonding. It consists of a bond type where a pair of electrons are shared by 2 atoms. The shared atoms, called shared pair, are contributed by each particular atoms. So every atom participating in this combination share the electrons. Covalent bonding results from the overlapping of electron clouds. In covalent combination, molecules and not ions are formed. So, in covalent bonding, molecules, not ions, are formed because the shared pair may be regarded as revolving in orbits controlled by both nuclei. This joint control of the orbits constitutes the valence bonding. Conventionally, the shared pair is represented by a stroke between the two atoms in the association. This is a stroke telling you that this is a covalent bonding. For instance, during your hydrocarbons combination, C combined to C, that's covalent bonding. Chlorine also combined to chlorine, hydrogen combined to hydrogen. This bond tells us that this is a covalent bonding. Diatomic molecules of elements are formed by covalent combination. Examples are chlorine and hydrogen molecules. Organic compounds are also formed by this method, e.g. the formation of methane. For this example, we'll look at the formation of hydrogen gas. It's an example of a covalent bonding. So before the bonding, hydrogen exists as a lone pair. Two molecules of hydrogen will combine to form hydrogen gas. But they are not transferring electrons, they are sharing the electron. You can see that two of them now combine. Here, shared electron pair, hydrogen molecules are formed. How does this form apply to nursing? Covalent bonding, electrovalent bonding, how do they apply to nurses? How do they work? Non-metals share electrons. Non-metals such as oxygen and water. Oxygen is relevant, water is relevant, and glucose is relevant. They are relevant to the nurses in the following ways. Oxygen therapy. Oxygen molecules bind to hemoglobin to deliver oxygen to the tissue, leading to avoidance of hypoxia or hypoxemia. That's oxygen, low oxygen in the blood, or oxygen not being able to reach the tissues. Another nursing relevance to covalent bonding are hydrogen peroxide. Hydrogen combining two molecules to oxygen in two molecules. Hydrogen peroxide breaks covalent bonding in bacteria, which is useful in wound cleaning. So hydrogen peroxide breaks covalent bond in bacteria, which is useful in wound cleaning. As I round off, we have to take note of the circles to success. Red circles tells you that these areas are necessary for your examination. So take note of the definition of chemical and physical changes. Take note of the understanding of ionic and covalent combination. Take note of how to write chemical formulas. You have to understand how chemical formulas are done. More of this will be done in class, so take those classes very seriously. Take note of the practical perspectives, which I will tell you about now. These are clinical perspectives of everything we have discussed. When you see sodium on the lab report, it's not just a letter. It's the reason your patient with diarrhea is dizzy. So sometimes you see they put up fluid for those having diarrhea. Number 2 clinical application is normal saline. Normal saline is a compound combining sodium chloride with water. But blood is heterogeneous, which is a mixture. If you treat them the same, you will cause a transfusion reaction. Thirdly, when you check the patient's serum potassium level, you are counting ions per liter, not just potassium. A difference of 1 millimole per liter can kill. Chemistry isn't in the test tube, it's in your patient's bloodstream. When you understand symbols, mixtures, and ions, you don't just give meds, you save lives. Answer these questions in the comment section. A nurse prepares potassium for IV push without dilution. Why is this lethal? 2. Giving a patient arterial blood gas as pH 7.28 and carbonate 18 milliequimoles per liter. Is this metabolic or respiratory? What chemistry explains this? Number 3. Why can't you mix calcium gluconate and sodium bicarbonate in the same IV line? Kindly drop your answers in the comment section of this video. In our next video, we'll look at Module 3, NUS 111, where we'll discuss acid-base salts and their characteristics. Before we go, I want you to take note of this possible examination question for your next exam. Differentiate between the physical and chemical properties of matter, giving 2 examples each. Is a possible exam question. Number 2. Explain the difference between a physical change and a chemical change as they occur in the human body, giving one example for each. Number 3, write the chemical symbols for any 10 common elements relevant to nursing practice: oxygen, sodium, calcium, etc. Question number 4, describe the differences between elements, compounds, and mixtures, giving one example of each as found in biological systems. Number 5, explain the particulate nature of matter by describing atom, molecules, and ion. Show how they combine chemically to form substances important in the human body. If you can answer these 5 questions, I tell you, you will be unbeatable at the exam hall. I want to thank you for staying tuned till this time. If you have not subscribed to our YouTube channel, kindly subscribe and tell us how you feel about these videos. Turn on your notification bell so you get new videos once they are uploaded. I want to thank you. We will meet again for Module 3. It's goodbye.